All right, in this video, we're going to do a quick recap of special right triangle rules. The reason why you want to know this is, well, there's actually a few reasons. First, this will help you have a deeper understanding of how the unit circle is formed. And then secondly, you're going to run into some problems later into probably later first semester or early second semester, depending on if you're an AB or BC, where you're going to be using some of these special right triangles rules to solve some problems. So there's two special right triangles. There's the 30, 60, 90, and there's the 45, 45, 90. Let's look at the 30, 60, 90 first. So 30, 60, 90, these numbers represent the angles inside of this triangle. 30 degree is the smallest one, 90 degrees is the biggest one, that's your right angle, and then 60 degrees is the middle angle. So we want to start off by locating the smallest angle, the 30-degree angle. So that's here on the left. It's not always on the left, but in this one it is. And if you go opposite the smallest angle, you'll hit the smallest side. So this right here is the smallest side. And so that's always going to be opposite the smallest angle. This could also be called a leg, so I might call it the small leg instead of the small side, but those mean the same thing. You might remember the legs are the sides that are adjacent to that 90-degree angle. They touch the 90-degree angle. And then down here at the bottom, if you go opposite the 60-degree angle, that's going to be your longer leg. And then opposite the 90-degree angle is your hypotenuse. And I might be misspelling hypotenuse, but I think that's it. Hypotenuse. Okay, so I'm going to label these. I'm going to label the small side A. The longer leg is going to be B, and then the hypotenuse is C. And we want to try to figure out how can we relate the length of the sides of a 30, 60, 90 triangle. And here's the way it works. You always want to start off with the smallest side. If you can locate the smallest side, everything goes through that. So I'm going to say that the smallest side is my x. There's some unknown length there, and I'm just going to call that x. But once you figure out what that length is for the smallest side, your hypotenuse is going to be double that. So whatever the smallest side is, double it, and that'll give you the hypotenuse. That would be 2x. And then your longer leg is going to be x times root 3. So you can kind of think it goes 1, 2, 3, except the 3 has like a radical around it. So that's how they relate. So let's look at an example of how we can use this. So let's say that I have a right triangle. I'm not drawing this to scale. So I'm going to put 30 degrees here. And let's say that I have a 5 sitting over here on the right. And I want to figure out what is B and what is C. Well, I know that my 30-degree angle is on the left, so if I go opposite that, that gives me the 5. So this is my small leg, my small side on the right. So I'm going to let that equal x. And then if I look at the diagram here, if I go from the small leg to the hypotenuse, all I have to do is double that length. That means that C, which is the hypotenuse, that would be twice whatever x was, 5. So my hypotenuse is equal to 10. And then if I want to find the value of B, that would be the small leg, the small side, which was 5, times the square root of 3. And then there's the other two sides. So we figured that out really quickly without having to use Pythagorean theorem. We didn't have to use any trig ratios like sine, cosine, or tangent. Even those would have given us those values. We didn't have to use any of that. We just used the properties of the 30, 60, 90 triangle. And then the other one here is the 45, 45, 90 triangle. Let's So there's a triangle inequality theorem that I can't remember the name of, but it basically relates the angle of a triangle with its opposite side, kind of like how we did over here. So opposite the smallest angle was the smallest side. So if you do the same thing over here, well, if you look at this 45-degree angle, this side is the opposite of that. And if you look at this 45-degree angle, this side is opposite of that. Since those two angles are the same, it makes sense that the two opposite sides should also be the same. And those are actually the legs of this. So when the 45, 45, 90 triangle, two of the angles are the same and the two legs are also the same. So I'm just going to say that these leg lengths are equal to x, some unknown variable. And let's actually derive what the hypotenuse is for this. So right now I'm just going to say the hypotenuse is c. And we know that if we have a right triangle, we can use Pythagorean theorem to find the length of a third side of that triangle. So Pythagorean theorem says that a squared plus b squared, that's the square of your two legs, is equal to c squared, that's the square of the hypotenuse. And here we said, well, the leg lengths are the same, they're both x. So this is going to be x squared plus x squared equals c squared. So if I add x squareds together, I will have 2x squared is equal to c squared. Now I really don't care about c squared, I want to find c itself. So I'm going to take the square root of both sides. 2x squared is equal to the square root of c squared. If I take the square root of c squared, that's going to give me just c by itself. Technically, if you take the square root of both sides, you need to put a plus or minus on the other side there. Because if you square a positive or you square a negative number, it's going to give you that positive term. However, since these values are for the distances or the lengths of a triangle, and you can't have negative lengths on a triangle, we can actually just ignore the plus or minus. So I'm just going to erase that. And then I'm going to break this 2x squared inside the square root up into two different square roots. And then I can take the square root of x squared to evaluate that as x. So this would be x root 2. That means that c is equal to x root 2. So whatever the leg length is in a 45, 45, 90 triangle, the hypotenuse is just that times root 2. In the future, you don't have to derive this every time. I just like to show you how to derive some things every once in a while. It can help you deepen your understanding with some math concepts. So let's do an example. Let's say that we have a right triangle. And I didn't actually put any numbers on this, but I did put the single arcs on each angle. And if you have the same number of arcs for each one, you might remember from geometry, that just means that these two angles are the same. So this indeed would be a 45, 45, 90 triangle, because if those two angles that are not the right angle are the same, well, they have to be 45s, because all of your angles have to add up to 180 degrees inside of a triangle. So this is a 45, 45, 90 triangle. So if I know that one leg is 3, well, the other leg has to be the same, because the leg lengths are always the same. And then I just have to stick a root 2 at the end of that, and that would give me the hypotenuse. So that's like super easy to figure out. Okay, so that's it for the special right triangle rules. The next video is covering the unit circle.